We're now moving into the second part of chapter 2, which is deductive reasoning. And in this section, we are going to be building on the concepts that we talked about back in section 2.1. You also may recall from chapter 1, we discussed inductive reasoning, and both types are important and critical for developing problem-solving skills, which is what chapter 1 was all about, and also critical thinking skills. But we're really going to be focusing on what's called deductive reasoning. It's a different type of reasoning. Both are, again, vital in academics, in careers, in your life. So we're going to start by looking at an overview of this section 2.2, and then we'll start with a little bit of an introductory activity. And so what you'll see here are the overview and terminology of what you will see. Again, we'll do an introductory activity. We will introduce you to what deductive reasoning is. We'll look at Venn diagrams again and see how those connect to deductive reasoning. Some of the terminology involved there: premises, conclusions, valid, invalid reasoning. We will talk about things called conditional statements. Those have terminology such as hypothesis, converse, inverse, contrapositive, logically equivalent, biconditional statements. So again, lots more terminology here. And then finally, we'll kind of put it all together. We'll do some reasoning using conditional statements. And there are a couple different laws associated with that, called the law of detachment and the law of contraposition. Now, I have an activity for you to get started with. And I'm not going to lie, these are one of my favorite puzzles. They're called Ken-Kens. And I don't know if you've ever seen one before. You may be familiar with Sudoku. Those are pretty popular, but I prefer Ken-Kens. I do one every couple days. And I time myself to see, it's not a race, but I always try to see if I can do it under a minute. And so there's a link in Blackboard. Here's the web address if you want to go to it. But what is a Ken-Ken? It's a grid that looks like this, like what you see right here on the page. Let me actually get a marker out. So it's what you see here on the page. It's this grid. And the numbers used in a Ken-Ken puzzle depend on how big your grid is. What you see here is a 3x3 puzzle. So it's going to use the numbers 1 through 3. If you do a bigger one, it's going to be like a 6x6. That's what I always do. Those are 1 through 6. When you first do this, if you go to that website and try these, I suggest you start simple. Start with a 3x3. Choose all 4 operations: add, subtract, multiply, divide, and then do the easiest one to start. Once you get comfortable, challenge yourself with some bigger ones, with some more challenging versions. But what you do, your goal of the puzzle is to fill in the entire grid, right? Fill in the entire grid so that no number is repeated in a row or a column. So you've got all 3 numbers, 1 through 3, in each row and column, but none of them are repeated. So how do you determine where they go? So what you'll notice here are these bold, blocked in sections of multiple squares, and those are called cages. They're the heavily outlined groups. And each cage has a target number and a math operation: add, subtract, multiply, or divide, in the top left corner. All right? 3, addition; 5, addition; 2, division; 2, subtraction, or just a regular old number, 3. And the numbers that you pick to fill in these cages must combine to produce whatever that target number is using that operation. For instance, there's a 2 square cage right here. It says 5 plus. So I could either use the numbers 2 and 3 in this little cage, or I could use the numbers, I could only use the numbers 2 and 3 in this version. If I were doing a bigger version, a bigger one, I could also use a 4 and a 1, but not for a 3x3 grid. You can repeat numbers within a cage, especially on the bigger ones, because some of the bigger versions will have cages that might go at an angle like that, like an L shape. So you can repeat a number within a cage, but not within a row or a column. Those are the only words. So I'll walk you through this one. So what I'm looking at here is, because that's number 3 only, I'm going to fill that within a 3. This then has to be a 2 and a 1. I don't know, though, what order they go in. 2 divided by 1 is 2, right? So I'm using division, and I would get 2 as an answer. But I don't know what order they go in. If I look across here, well, again, remember the 5? The only way to make a 5 is with a 3 and a 2. And because there's already a 3 in this row, then there can't be another 3. So what does that mean? It means that my, to undo that, it means that my 2 has to go on top here, and my 3 has to go there. 2 plus 3 is 5, because I couldn't have that 3 up top. I can also fill in this column because I know that a 1 would have to go there, because I have to have all 3 numbers. Looking across the top, this is a 3, this is a 2. That means a 1 has to go here to fill in the rest of that row. And this cage has to add up to 3, which means this has to be a 2. 1 plus 2 is 3. Follow it down. 1, 2. This has to be a 3. 3 minus 1 is equal to 2 using subtraction. Continuing that idea of filling in the row, this would have to be a 2 because I need to have all 3 numbers there. And then I can finish it off with a 1 there. 2 divided by 1 is 2. And again, no numbers repeat in any of the rows or in any of the columns, and all my operations are correct. So my challenge to you is to go give that a shot. Try a few of those when you get comfortable. Try some more challenging ones. This is a perfect example of what we're going to be doing in this section, deductive reasoning.